Okay, so I want to go through some examples of a couple different kinds of questions you might see, and so I'm just kind of picking a few. So this is number three, and one of the applications or something you can answer using geometric sequences or that summation formula is something like this, like a bouncing ball. Now, the idea here is that our ball itself is going to be bouncing like straight up, straight down, straight up, straight down. So it's just like dropping like that, right? Just for sake of ease, let's expand it. So like if you were to open it up almost like, okay, so you could pull it apart so you could see each height. That way it might be easier to start labeling things. So it continues forever. Okay. So it says that it'll always bounce back 97% of the distance it's dropped from. So it's going to originally be dropping from a height of 150 feet. So it's going to drop, it's going to hit the ground. And then when it gets the top here, that's 97% of 150. And then it'll bounce back down, and it'll be 97% of that, which is 90% of 90%, or 90%, 97% squared of 150. And then it bounces back down, it bounces back up, and now it bounces up 97% of that, which is 97% cubed of 150. And so every time it bounces back 97% of the previous height. And so we have this common ratio. This R is 0.97, and we know that the first height is 150, and then the second height would be 97% of that. So my first term is 150, and so it's an infinite geometric series, and we know a ratio is less than 1, so we can figure out that the sum is equal to A over 1 minus R. And so our height is 150. And then we do 1 minus 0.97, which is 150 divided by 0.03, which is 3/100ths. So 150 divided by 3/100ths. So doing this by a calculator, 3 goes 150 50 times, but then we're multiplying that 100 up, so it's really going to be 5,000 feet. Now, the thing is, that's only half the battle, because that's just the down. And then let's say down, right? Down. Like, we have to also account for the fact that it's bouncing up. And so we're going to double those values, but there's one that doesn't get doubled, right? Because your ball's not starting from the ground shooting up. It's starting from 150. So I can double that. So I can take that times 2 to account for all the upward motions or the downward motions, depending on which one you counted. But then I have to remember that the first one doesn't get doubled. So we take away 150. So that would be 9,850 feet total. So 9,850 feet. Okay, now, I don't know why I have dollars. I got money on my mind. That's so funny. Another way you could solve this is if you just started with the ones that get doubled, right? So you could have just started here and said your first term was whatever 97% of 150 is, doubled all those, and then just add 150 in. You'd still get the same value. Okay, another example, this algebra problem. Find x so that these three terms are in order and are in a geometric sequence. Well, one of the properties of a geometric sequence, if you remember, is that, so if you have A1, A2, A3, like they form a common ratio. So any two consecutive terms, so if you compare A2 to A1, it'll equal A3 to A2. You could see that, just with a geometric sequence, like if you had one, like let's say you have 1, 3, 9, 27, 81, 243, right? You're just tripling your values. So take any two consecutive terms, like maybe 81 to 27. Oh, that's a ratio of 3. Take these two, 9 to 3. Oh, that's a ratio of 3. So any two consecutive terms have that common ratio. That's what makes it a geometric sequence. So I can set up an equation then. 10 compared to x minus 8 has to have the same ratio as x plus 2 to 10. So then, so we can solve this, cross multiply. So get 100 is equal to the quantity x plus 2 times x minus 8. So we want to simplify that out. X squared minus 6x minus 16. And then we will go ahead and subtract 100. So 0 is equal to x squared minus 6x minus 116. And so then, factoring like, oh, well, maybe this is, a little bit tough to factor, and that's fine if it is. So then what you can do is complete the square if you want. So 0 is equal to x squared minus 6x. We would say half of 6 is 3 squared is 9. So then we would immediately subtract 9 from that particular value. And so then, sorry, I'll make sure I did my math right. That's right. Okay. So we subtracted 100, so we get 116. So then this would be 0 is equal to x minus 3 squared minus 125. And so then we can add the 125 over. We get x minus 3 squared. Introduce the square root, so we get plus or minus the square root of 125 is equal to x minus 3. Add 3 over, so 3 plus or minus, and square root of 125 is 5 root 5 is equal to x. And so, like both of those values will work. And so then we just say our values of x are 3 plus or minus 5 root 5. All right. Next. Another bouncing ball one. Okay, excellent. So it says my Mr. Brown's best bouncy ball bounces back B% of its bounce each time. Okay, so that's great alliteration there, right? They all start with a B sound. If the ball is originally dropped from a height of 8 feet and travels a total distance of 312 feet, find the value of B. So it's kind of like setting up an equation where, okay, we're dropping 8 feet, and then it bounces back a certain percentage of that 8 feet. And again, another certain percentage of that 8 feet. And I really don't know, so that's 8. So I don't really know what that percentage is, but if I call it like r percent of 8, and then this would be r squared percent of 8, and it'd be like r cubed percent of 8, because every time it bounces back another, right, r percent of that. Or I guess B% of that. So I'm using R because of the rate. So I guess that could be like B percent, B, right? B squared there, okay? So just like we did last time, like our total sum would be A over 1 minus R. Our initial height is 8. 1 minus our ratio, which we don't know. Call that B. But we know the total distance is 312. But remember that 312 represents doubling everything. So we're doubling that. But then we're taking away that first 8 because that 8 doesn't get doubled. So I can come up with an equation that is right here that represents that total distance. Okay, again, remember A is the total, or the original, or the starting height. 1 minus the ratio of B. You double everything, so that also get the 8 though, right? So it's getting up and down, but then you take away that 8 because you are dropping it from the top height. You're not like shooting it off the ground or throwing up on the ground. So let's solve that. We would add the 8 to both sides. So then I would get 320, and then I would have I could multiply the 2 times 8 to get 16 over 1 minus B. And then what I might do is multiply this across. So 16 is equal to 320 minus 320B. Subtract the 320. So I get negative 304 is equal to negative 320B. Divide by negative 320 to get our B value. So then B would equal, let's come on, guess down over here. So B is equal to 304 divided by 320. So then, well, I know those are both divisible by, they're both divisible by 4. They're both probably divisible by like 16, I would guess. So let's give it a try again without a calculator. So I know it's going to be a 20. 16 goes into 304 once. That's 16. And then we get 144. So it's 19. So that's 19/20ths. So my B value is 19/20ths, which would be 95%. It's already asking for B as a percent. So we can say B is equal to 95. Okay. I like this number 8. Kind of coincides with one where they're in order. So when I look here, like these are in a geometric sequence. So I know that the consecutive terms, like 2 over B1, would have to equal like B3 over 2 would have to equal 50 over B3. And that probably is the one I'm going to start with because that's where I can actually solve, right? I can cross multiply. So I could say 100 is equal to B3 squared. And then I could square root, so get plus or minus 10 is equal to B sub 3. Well, then in this equation, now I know that 2 over B sub 1 is equal to plus or minus 10 over 2. And both of those values will work because remember we saw again alternate positive to negative, you'd have the same ratio. So I could cross multiply. So 4 is equal to plus or minus 10 B sub 1. Divide that across. So we get plus or minus 2/5 is equal to B sub 1. Okay. And then I think there's just one. Oh, well, let's jump down to example 10 here. So example 10, I just wanted you to be aware that, looking for patterns, I'm noticing that, yeah, the bottom definitely is geometric, but the top is not, but it's alternating 3, -5, 3, -5, 3, -5. So if I think about that and separate that, like 3 over 2, if I take just the ones that have 3's in them, 3 over 32 plus and then I could say plus -5 over 4 plus -5/16 plus -5/64, right? So all of them separated, these with 3's, they are a geometric sequence, and its common ratio is 1/4 each time. So my ratio is 1/4. Here, my ratio is still 1/4, right? But it's a different starting term. So I would break this up into 2 sums. Since adding is commutative, right? It doesn't matter the order. You could rearrange them. So this would be A over 1 minus R with a starting term of 3 over 2 and then 1 minus 1/4. So then that's 3 over 2 divided by 3/4, which is equal to 3 over 2 times 4/3. So that much of it is a value of 2. And then over here, my starting term is -5/4 over 1 minus 1/4, which is -5/4 over 3/4. The fourths would cancel. We get -5/3. So we have a sum that's equal to part of the terms equal 2. The other half of the terms equal -5/3. So then together, our overall value would be 2 plus -5/3. We could think of that as 6/3 minus 5/3, which equals 1/3. Okay. So again, just maybe some help on some of the maybe more challenging problems or problems you haven't seen before. Sometimes it's nice to look through and watch and go through a solution.